What did I miss? On Friday.
We started circles.
Yeah. Oh, we started.
Yeah, so we started. Between we're going to. So, I feel like it's a bit of a-
You're good? Oh, yeah.
Maybe that one that's used, not high school, I just. No, that was the.
It was like all of a sudden, I didn't even look at it.
That's like, well, it's not checking for like, it's so much good.
So, let's go to page 12 in your packet. Just to recap a little bit, what we did on Friday, we learned about circle equation, which is basically looks a lot, basically rearranging of Pythagorean theorem and distance formula. We learned that your HK is the center of your circle, radius is the distance from the center to a point on the circle. We use the midpoint formula. Sometimes you're given information where you can use the midpoint formula to get from the endpoints of a diameter to the center. And then we also use distance formula, but really it's the same thing, which is if you square both sides of the equation, you're arriving at the circle equation. Okay, so again, x, y represents any point, all the possible points on the circle. H and K is the center of the circle, and R is the radius. Okay, so if we look at page 12, here's our standard form. Now, this is in standard form. It's missing all the parentheses, but really we can rewrite this using parentheses and just put x minus what? 0, right? You can just put 0 if you want, and basically it's doing away with all the zeros because you know the zeros can just go away. But if you write it out with everything in this proper form, you don't have to do this, but if it helps, that may help. That may match and find your center a little bit easier. What's the center of this circle here? 0, 0. And this side is related to the radius, but it's not usually the radius. So what do we need to do to get down to the radius? Get the square root, right? So square root of 4 is 2. Okay. And we talked about how if we want to graph a circle, we plot the center, and then we go up and down, left and right 2 units, and we use the 4 points to create our circle. Okay. All right, let's look at the next one here. Oh, sorry, the direction said, what if the equation for this circle is not already in standard form? The following are circles. Our equation of circles can identify the center and radius for each circle. So this one is also in standard form. Okay. What's the center? Okay. We always take the opposite signs of what we see inside the parentheses, just like how we did with parabolas. The radius is not 20, but what? Square root of 20, right? Which should be used for, you know that root 25 is 5, root 16 is 4. So somewhere between 4 and 5, we can kind of just estimate it to be somewhere like 4.5-ish. Right? You can also use your calculator to get a more accurate decimal value. Now, the third one here is this in standard form. Okay, we don't see a set of parentheses, so guess what we have to involve to get it into standard form? Yeah, complete the square, just like how we did with parabolas. Okay, but we can, but we're not going to have to put the x squared on one side and y's on the other. Notice how everything is on the same side of the equation. So what we're going to do is we're going to use the space here to work this problem. Okay, we're going to group all the x's together, group all the y's together, and then on the other side we're going to put the constant. Okay, so the constant is going to kind of work towards getting that radius. Okay, so let me rewrite my equation that I want to start with. All right, now we've had practice with completing the square, so hopefully, now the challenge here is that we're going to have to complete the square most likely twice, once for the x, once for the y. So the process is not going to be different. It's just going to feel a little longer because we got to do both sets of x and y. So I'm going to group the x's together. Leave some space because I know I'm going to have to put a plus space in a little bit. Okay, and then we group the y's together. Notice that everything's on the same side of the equation, so there's no need for me to move things from one side of the equation to the other. So that's why I'm not changing these signs. Whatever they gave me to begin with, I'm going to keep those signs. But the 9, I do want to move to the other side because that is going to I'm going to have to use that to help me with the radius information on the right side. Okay, everybody okay so far? Grouping the x's, the y's, and the constant on the other side. So we're trying to work towards our standard form, right? So we are going to get the x's grouped and factored, and the y's grouped and factored, and then we're also going to clean up this side. All right, so we're going to have to add spaces to both ends. So if I have 2 spaces here, what do I need on the other side? Also 2 spaces. Yeah, so I need to maintain balance. Whatever I decide to add and change on one side, I got to make sure I keep that same balance on the other side. Otherwise, we're not working with the same equation anymore. Something has changed. All right, so the formula that we're going to use, b over 2 squared. Same formula, but we're going to do this twice because different b values for different variables, right? So what's the b value for the x? Yep, 6. Again, I don't worry about the negative because I know it's going to get squared, so it's always going to end up being a positive value. So 6 over 2 is 3. 3 squared is 9. So 9 will go here, and 9 will go here as well. All right, repeat the same process for the y's. Okay, my b value is 8 for y, so 8 over 2 is
16.
Yep, 16. So 16 goes in the first space, 16 goes in the other space. Okay. So now we're going to look to factor, and we're trying to reach this goal here. Right? So we ask ourselves, what 2 numbers multiplies to be positive 9, but we want the same 2 numbers to add up to be a negative 6.
Nicely.
So x minus 3, x minus 3. Okay, I'll come back and I'll merge those together in a second. Multiplies to be 16, adds it to be 8.
5 minus 4.
This can be the same 2 numbers though, 4 and 4, right?
Yeah.
Okay, good. Yeah, plus 4. And then the right side, this adds up to be just what? 16, right? The negative 9 and 9 goes away. Now it's nice and clean in standard form. If you don't want to write the second step of writing the x minus 3 twice, you don't have to. You can jump directly here. I just wanted to show that, we're creating 2 of the same binomials, and that's why it merges together to be x minus squared. Right, so now standard form. Now we can find the center and the radius. What's the center of the circle?
3 negative 4.
3, negative 4. And the radius is
4.
4, right? Now, square root of 16, you may be thinking, oh, this is plus or minus 4, but principal values, it's just going to be a positive number. Okay. All right, so let's try number 1 together. Same process. Notice that this is not in standard form. So we're going to group the x together, group the y's together, push the constant to the other side. Okay, so as you guys work on it, I'll work on the same time as you. All right, so check your work with mine. Any questions? Okay, take a look at number 2. Also not in standard form. We're gonna complete the square, but what's causing it difficult? Or what's making it difficult for us to complete the square? Yeah, the coefficient cannot be anything other than 1. So we're gonna have to divide it out. Okay, just like with parabolas, when we're doing parabolas, we're always focused on, okay, what variable do I need to complete the square for? I can't, it's hard to complete the square with my coefficient being other than 1. So we'll just go ahead and I'm gonna just divide everything by 4. Right? I can. Oh, actually, that 2 divided by 4 is a little messy, so I'm gonna just try to do something here. I'm gonna at least move that 170 with the 2 before I divide by 4. Because I see everything is divisible by 4, but that constant is giving me an issue. So I'm just gonna move those 2 numbers together. I mean, I can divide by 4 right now, but then I'm dealing with 2 fractions. Eventually, fractions do combine, but if I can just avoid fractions to begin with, just do 170 plus 170 plus 2. Now this feels a little bit cleaner here. Divide everything by 4. Right, we should have some nice whole numbers here to work with. Okay, 174 divided by 4. Sorry, 172 divided by 4. 43. P over 2 squared. 2 over 2 is 1. 1 squared is 1. 8 over 2 is 4. 4 squared is 16. Something that I wanted to keep reminding us is that anytime you complete the square, you're only dealing with positive numbers that you're building. Okay, so any of the spaces that you create, there will only be positive numbers. So if you end up having a negative number in there, something didn't go quite right. Okay, so we only are dealing with positive numbers for any of the spaces that you create. Okay, so factor multiplies to be 1, adds it to be -2, -1, -1. At multiplies to be 16, adds it to be 8. Right, 44 plus 16 is 60. Root 60 is not going to be a pretty whole number, but you'll just make your best approximations also on the graph as well.
Wonder if I could go to the media center to watch today's videos on the notes, so I'm not confused from missing this first part.
Okay.
Usually if I'm late, I try, I just don't understand where we're starting.
But you be calm.
Yeah, I watched up everything.
So it's around 7.75. I'm going to just make my best estimation on my graph here. So 1, -4. It's my center. Okay, any questions here? Let's go to practice on page 13. So with what we did, either complete the square or having to divide that out, is that okay with you guys? Does that feel okay? All right, so I'm gonna skip 1 through 3 because it's just basically the same thing that we've done before. I want to go to number 4 just because this requires a little bit of rearranging. It's not that much more difficult, but I do want to walk through the step. Right, it's like, what if everything is out of place, right? But it's the same process. We're gonna get the x together, get the y together, and then the constant on the other side. Okay, so this one here, I could move everything to the left side, but I find that it's easier to move the 3x squared to the right side. That way I don't have to change as many signs. Because ultimately you want your x squared and y squared not only to not have any coefficients, but we also want them to be positive. Okay, so I'm just going to kind of go down the path of least resistance and just try to get this to work. Okay, so I get the x squared and y squared together. I haven't taken care of the 3 yet, but at least the signs is where what I want it to be. I want the x squared and y squared to be positive and on the same side, and my constant on the other side. Okay, are we okay with this here? Okay. Now, after this, I'm just going to make it more familiar. So I'm going to put this on the left side and put this on the right side, but I'm just going to rewrite it. I'm not going to change the signs, but it just feels more familiar when we're just working on the left side and just having the constant on the right side and just flipping. Yeah, but I'm not changing any signs. Okay. All right, what do you think we can do next? Yeah, let's get that 3 out of the way, right? So everything by 3. All right, we're going to have to complete the square, but do we need to do it for both variables? Just the what? Just the y, right? You only complete the square if you have like x squared and like 4x. You have x squared and x together. Here, this really, the x is just really x minus 0 squared. So that's clean. Nothing that we need to do with the x. It's just the y's that we have to get it cleaned up to be a parentheses. So I'll leave the x alone. And I just need one set of complete the square for the y's. Okay, so try those steps, see if you can finish the problem, and I'll work alongside you guys.
Gonna get to use the calculator on the test. So like, right here.
I want to say yes, but I forgot what the I was looking at the test from last year. I don't remember what we did, so let me get a clear answer for you by tomorrow. But I think I'm going to say yes for now. Okay, let's begin our review. Our quiz is on Wednesday, and it's just going to be over circles and parabolas. So why don't we work through the odds, and then I'll just kind of talk through the problem, and then tomorrow we'll do another review worksheet. We'll finish this, do another review worksheet, and I have a third review worksheet that you guys will hopefully use as a way of practicing Tuesday night. Okay, and then I can also have a help session Wednesday morning going over that third review worksheet. Okay, so let's talk through parabolas here. So identify the characters of a parabola graph and label the parts. So we know that we're always working with one of two formulas, right? It's either going to be x minus a squared, which is vertical, up or down, it's either opening up or down, and then y minus k squared, which is either opening left or right.
Are we gonna have to memorize this?
Right, you gotta memorize the formulas, yeah. Okay, so in this case, the y is being squared, so which direction are we expecting? Up, down, or left, right?
Left.
Left, right, okay? And then this 12 is gonna help narrow down even further. That's a positive 12, so it's gonna open to the right. So if it opens to the right, let's go ahead and do a quick sketch so you know where things are. You expect these things to be in place. Just to have a nice sketch so that you know what you need to accomplish, right? You need to find the vertex, the focus, the directrix, the axis of symmetry. You also know where they're going to be in relation to each other. All right, so you're gonna have to memorize these formulas here. This the one that we're working towards is y minus k squared equals 4px minus h. How do we find the p-value? Set 12 equal to 4p, yep. So divided by 4, p equals 3. All right, what's the vertex? Good. Follow the x first. Your h is with the x. Your k is with the y. So negative 1, 3. Always change the signs as well. I have my vertex. I can move left and right 3 units to get to my focus, and the point that will be where my directrix will be. Here, here. Directrix is it's not a point. Okay, so make sure that you don't identify directrix as an order pair. I just plot a point here so that I kind of know where to draw that vertical line. And then your directrix and axis of symmetry, make sure you don't just provide a number. You got to give me the equation of a vertical or horizontal line. Focal width. So look at that word focal. That reminds you of focus. So you know you're going to go from the focus. You're going to go up and down 6 units because you want from end to end to be 12. So we don't want to go up 12 and down 12. That's too long. Okay, so up 6, down 6. Actually, let's go ahead and do 2 and 3 since 2 requires complete the square. So I want us to practice complete the square. for parabolas. It's only for one variable, okay? You're not going to complete the square for both variables when you're just dealing with parabolas. Okay, number two, which variable is squared? X. So we want the x's together on the left side, everything else on the other side. I'm going to complete the square for the x's. Fill in that space, b over 2 squared, 4 over 2 is 2, 2 squared is 4. Multiplies to be 4, adds it to be -4, -2 and -2. Combine like terms here, 8y minus 8. I can clean the left side up and I can take a GCF out from the right side. There's my standard form. I'll put that up here. All right, go through the steps. X is squared, the 8 is positive. You know how your parabola is going to look. Focus on the inside, directrix on the outside, axis of symmetry. So it's good to have a quick sketch so you kind of keep looking at it and have an idea where you expect things to go. Okay, number 3, write the standard form of the equation of a parabola with the focus at 4, 2, directrix at y equals -8. So we're going to kind of put these in place, and then we can kind of decide, okay, which formula do we want to target? Okay. So let's plot what we have here. Focus is at 4, 2. Directrix is at y equals -8. That's a horizontal line. So this look like a lot of information, but this should be enough for us to get everything that we need. how is the parabola going to open? Just by this alone. Up, yep, see, that's the only way this is gonna work, right? The only way that directrix can be below the focus is if the parabola opens up, right? You know your parabola, focus is inside the parabola, your directrix is outside. So what information can we get if we know the focus and the directrix?
Radius.
Vertex, right? Where's the vertex gonna be? Okay, how did you find that? It's between, yep, exactly. You focus, if you have your ends focus in your directrix, you know your p-value, sorry, your vertex is going to be in between. If you can find your vertex, then you can count and you can figure out your p-value. Right? It's always going to be lined up like this, and they're always going to be same distance away from each other. So I'm going to count the distance here. 1, 2, 3, 4, 5, 6, 10. So 10 units separate them. So that means if I go 5 units between them, vertex must live there. And if I know there's 5 units between the vertex and the focus and 5 units between the vertex and the directrix, my p-value must be what? 5. And I know it's opening up. So if it's opening up, I expect my p-value to be positive. And I know what formula that I want to target is going to be the x minus h squared. All right, so now we have the p-value. We can figure out what the vertex is, and then we can put our equation in standard form. Okay, what's the order pair of your vertex? 4, -3. There's your H, and there's your K. P-value is 5, we found that, so there we go. We're ready to put everything into standard form. Four times 5 is 20. Change the sign. -3 becomes +3. Focal width, I know it doesn't say it, but let's go ahead and just graph everything, right? So I'm gonna go 10 units. All right, it's gonna be way off here. Okay, very wide travel. Let me just do 2 more problems, and I want us to review what we did last on Friday with circles. So if you guys can turn to page 15, and whatever we don't finish, we'll finish tomorrow. I want to talk about number 8 and 9 here. Find the equation of a circle whose center is 5, -2, and contains the point -3, 1. Now, we know what the equation of a circle is, so I'm going to go ahead and put that down. Now, what we have is we have some temporary information that's going to be useful. We know what the center is. Center is HK. And then the point is some random point on the circle. is not going to be in our final equation, but it's going to help us because if I have a point and a center, I can use that to solve for R. And you guys have mentioned in the past, can I use Pythagorean theorem? Can I use distance formula? Yes, because this is the same, really it's the same equation. I just find it easier to just involve one equation. So I'm going to insert the HK and the XY temporarily to help me solve for R. If I can solve for R, then I can come back and write the equation in the circle. Okay, just replace the HK and the R. So now every time you want to do this, make sure you change the signs for your HK, but then your XY will stay the same signs. Okay. Oh, I'm sorry, I messed up. Try again. Okay, X minus H should be -3 minus 5. And then Y minus K is 1 plus 2. So there's my R squared. That's exactly what I need for my equation. So all I want to do when I write the equation is I want to replace the HK and the R, but leave the X and Y as variables. All right, so I'm going to write my equation now. X minus 5 squared plus Y plus 2 squared equals R squared. R squared is sitting here for me here, 73. So this is my answer here. Okay, one last one here. Find the equation of a circle whose diameter has endpoints 4, 9, and 20, -11. So I have endpoints of a diameter. I know diameter is going to go through the center. What information can I find with the 2 endpoints of a diameter? Not vertex, but midpoint, which is going to be the what of the circle. Center, right? So yep. So we use the midpoint formula because we have 2 endpoints of a diameter. We can use midpoint formula to get to the center. If we get to the center, then we'll do the same thing here. Pick a point as XY, find radius, and then get to our answer. Okay, so midpoint. Midpoint is adding the x's together divided by 2, and then adding the y's together and divided by 2. So 24 over 2 is 12. -2 over 2 is -1. That's my midpoint. That's also my center. So I'll call this HK. Now I can choose either point for my XY. It doesn't matter. I'll just arbitrarily choose what I think is easier to plug in, since these are the smaller numbers. So temporarily, just like before, I'm going to use my circle equation to help me get to R. If I get to R, then I'm just inserting back into the equation. Okay, so X minus H squared, Y minus K squared, -8 squared is 64. 10 squared is 100. I have my radius, I have my center. That's all I need to build my circle equation. I just want to make sure that I can do an overview of all the things that we're expected to do, and then tomorrow we'll get we'll finish this practice, we'll do another practice, and then play on Wednesday. All right, come and get your phones.
I don't know if I did it right.
You just put into the simple formula, see if your radius is larger or smaller.
Okay, yeah, because I tried to get like,
Distance formula.
no, like, what's it called? Jesus. A square plus b.
Yeah,
There,
yeah,
yeah, yeah, yeah. I know it's all the same, so, okay.
Same, yep.
That's what I thought. Thank you.
Sorry.